Hello and welcome to our GATE-CSE-IT tutorial. In this lecture, we are going to discuss three new problems on the topic array. Let us consider the problem number 3. Consider an array consisting of negative and positive numbers. What would be the worst time comparisons an algorithm can take in order to segregate the numbers having same sign altogether? That is, all positive on one side and then all negative on the other side. Now in this problem we can consider we have an one-dimensional array A with n digit, that is the size of the array is 1 to n, which consists of positive and negative numbers, and our job is to segregate positive numbers in one side and negative number in other side. So we can consider this is a partitioning problem, and we can use the partitioning algorithm of quicksort. So we can take the leftmost element is our pivot element, and second element is our leftmost pointer I, and the nth element is our rightmost pointer j, and each step I will compare the element with the pivot element, and if the element is same with the pivot element it will increment it, otherwise it will stop, and each step j will compare with the pivot element, and if it is same with the pivot element it will stop, otherwise it will decrement it by 1. Whenever I and j both are stopped, they will swap the value of each other. Like here in first case I will stop here and j also stop here. So because the pivot element is positive, so our job is to segregate all the positive values in left and all the negative values in the right. So I and j will stop, they will interchange the values. After that I again incremented by 1 and j again decremented by 1. How much they will increment it and decrement it? The end condition is when I is greater than equal to j, in that condition will stop. So here we have to have n minus 1 number of comparison, because I will start from second element, so total number of comparison will be n minus 1. So our answer will be a n minus 1. Next, come to the problem number 4. A program P reads in 500 integers in the range 0 to 100, representing the score of 500 students. It then prints the frequency of each score above 50. What would be the best way for P to store the frequencies? Here in this problem, we have 500 number of students, and all the students had gone through an exam where the maximum marks is 100. Now the problem will print the frequency of each score above 50. That means we need to find out how many number of students got 51. Let's say this is n1 number of students. How many number of students got 52? Let's take this is n2 number of students. In this way up to 100. How many number of students got 100 in the exam? Let's say this is in 50. So we have 50 different number. So we need to store 50 different numbers. The best way to store the frequency, we can think like an array of 50 numbers. So this will be our answer A. Now let's come at the problem number 5. Consider an array A1 to n. It consists of permutation of numbers 1 to n. Now compute another array B1 to n as follows: B ai is equal to I for all I. Which of the following is true? So in this problem we have an array A with size n. The array contain the value between 1 to n of any combination of 1 to n. So before looking at the options, at first we'll take an example of array A. Let's say A. Let us consider here n is equal to 8. A is an array of size 8, and since A will contain the value between 1 to 8 of any combination, let us assume a combination. For example, let us consider this is the combination of values between 1 to 8, and this is the array A. Now if we generate the value of array B, how could we generate the value of B? The formula is B A I is equal to I itself for all I belongs to 1 to n. So it is clear that the size of the array B is also 8. B is also an array of size 8. I is equal to 1, then B A1 is equal to B A1. The value of A1 is 4. So B4 is equal to I itself is 1. So B4 is equal to 1. In this way, you can generate the value of B array. It will be, so this will be the value of array B. So now if we can look what are the options are given. Option A, B will be a sorted array. Clearly this is not a sorted array. So this is cross. B is a permutation of array A. Yes, B is a permutation of array A because this B also contain value between 1 to 8. So this is another permutation from 1 to n. So this is true. Next, doing the same transformation twice will not give the same array. That means if transform B with the same transformation function, we will not going to get the array A. We don't know whether this is true or so we have to prove whether this is true or false. Next, B is not a permutation of array A. This is false. And none of the above is true. This is also false because we know this option B is true, and now we have to check whether this option C is true or not. For doing this, let us consider another array C. And how could we generate the value of C? Using the same formula. So we are going to use the same formula twice. We generate B from A using the same formula, and again we are trying to generate C from B using the given formula. Now we are going to check whether C is the array A itself or any other different array. Now if we generate C, for example, let us consider one value I is equal to 1. In that case, C B1 is equal to, what is B1? B1 is 6. C6 is equal to 1. In this way, we can generate all the values of C and it will look like, and we can check that A is equal to C. A and C both are the same array. So this option C is not true. So this option C also false. So our answer will be B. In this lecture we have discussed 3 different problems from the topic array. In next we are going to discuss more problems in data structure. Thank you.